To look at another example now. Now, there's a few things I need to remind you of, and remember I'm working from the critical exam revision set, so I'm not doing things from scratch, right? I'm assuming you have certain knowledge in place already. I do want to point out that I've given you two golden rules in the previous video set. I said when we learn this, we need to work on something called foresight, and we build up the foresight using practice, right? And those were my golden rules for trigonometry, especially with the section on identities, simplification, and those sort of things, right? And we need these two with each other. Now, often I get students and they want to know, they sometimes don't think they know where to start, right? Sometimes they want its direct route to the answer. Now, the way I see trigonometry is I see that you need foresight and you need practice. And foresight is basically when you start seeing 3, 4, 5 examples. Sorry, not examples, or steps ahead, or even the answers at times without actually working the things out, right? And that's only going to come through practice. The second thing I want to say is that you must make mistakes. You got to make mistakes. The only way you're going to work through the mathematics is if you work on your technique, you get things wrong, and then you start seeing where you should be getting them right. And through that, you'll also build up seeing the more appropriate way, the easiest way, the shortest ways, and so forth. So the best thing I can recommend for while you work through the section on trigonometry is do as much practice of your identities, learn them, have your summary sheet at hand, and just do a lot and a lot and a lot of practice. Okay, I'm going to show you two examples now. I'm going to show you two examples, the same question, but I'm going to use two different identities, and you'll see that both of them come out correctly. Now, a common question I get in the classroom is, must I always use this one? Should I not? But that one's easy. I should always use that one. And the reality is, in an examination setting, you just got to use any of them as long as you come to the answer. Okay, so let's look at the example. This is a very, very simple one. It's square root of 1 minus cos squared, right, divided by cos of A is equal to tan of A. Right, so again, this is my left-hand side, this is my right-hand side, and I have to then indicate that I'm working with the left-hand side in order to prove the right-hand side. So I say left-hand side is equal to square root of 1 minus cos squared A all over cos of A, right, is equal to. Now, this is a very simple identity. Very, very simple one. 1 minus cos squared is given. It's something you've seen in grade 11. You know 1 minus cos squared is actually sine squared A. So then I'm just going to replace that square root with the thing under it and make that sine squared A. Okay. The denominator is just cos A, which is already an acute angle. It's already an angle less than 90, so I don't have to stress. I don't have to worry. I can just simplify this further now. And that's going to give me square root of sine squared. It's just sine, like the square root of 2 squared is just 2. So that's just sine A. And this is divided by cos A, which is just still cos A. And sine A divided by cos A is also an identity, very simple. That's going to give me tan of A. Now, as you can see, tan of A was on the right-hand side, and now I just say is equal to right-hand side, and my job is done. Now, I want to show you where we can actually use another identity. If you didn't replace 1 minus cos squared with sine squared, you could have actually replaced cos squared. I'm going to show you that, just to show you that we'll still get to the same answer, and that both ways will still be correct, right? So let's say I had a question, square root of 1 minus cos squared A divided by cos of A. Okay, let's simplify the numerator first. I could say that this is equal to 1 minus, but now I've got cos squared A, right? Cos squared A, if I go to my summary sheet, I can see that cos squared A is equal to 1 minus sine squared. So I go here and I change that into 1 minus sine squared A. I hope you can already see that this is going to turn out to be exactly the same thing, divided by cos of A. Okay. And if I simplify the top, I've got 1. I multiply this in, that into that, I'm going to get minus 1. And I multiply that into that, I'm going to get positive sine squared a. Right, and I'm going to then divide. And I get cos of a at the bottom, which is already there. Now this 1 minus 1 just becomes the square root of sine squared a divided by cos of a, and that's simply equal to sine of a over cos of a. And sine of a over cos of a is a known identity. It is equal to tan of a. Right. So for argument's sake, I could have said that that is left-hand side is equal to this thing. I've proven it all the way down here, and I've concluded that this is the right-hand side. And now I've shown that the left-hand side is equal to the right-hand side in the same way that I've shown that the left-hand side is equal to the right-hand side. I've used two different identities, although both identities were correct and true, therefore they will still get me to the same answer. Okay, so good luck. That's example number 3.